Okay, so I explain here a bit about neural networks, very basic. If you have any questions, just let me know. It's a bit, I'll try to do it not technical, just very simple. So you've got here a neural network. If you put neural network in Google, you'll find this is one of the pictures I found. It doesn't really matter, but anyway, so you have here the input layer. This is very simple to understand. Then you have here the hidden layers. That's why they call it deep. They call it deep because you have this and that. So the more rows you have, these called columns. Sorry, these are called columns. So the more columns you have, the deeper it is. They call it like that. There's nothing deep about it. It's just there's more stuff in it, but it's in this way. Okay. So what you have is the input layer. Then you have the hidden layers. Sorry. And hidden layers, I'll tell you why this is called hidden layers. And then you have the output layer, okay, which is a 0, which can be a 0 or a 1 anyway, doesn't matter. These two are output layers. So because you have two output layers, what you can have is an outcome about two things. For example, output 1 means, is this a 0 or a 1? For example, if you're asking the question, should I go left? And to a machine, right? You say, should I go left? A 1 here, if you get a 1 here, means yes. If you get a 0, it means no, okay? If the question here for this output was, should I go right? If you get 1, it means yes. If you get 0, no. So it becomes immediately clear that if you had 1, 1, it would be, should I go left? Yes. Should I go right? Yes. So that's impossible. I can't go left and right at the same time. That means that the neural network has made a mistake. Again, if you got 0 and 0, should I go left? 0, no. Should I go right? 0, no. So it means don't go left or right. That's fine. I just stay the way they are. For example, I just gave you a very simple example, and I started by the end, by the output. This output means the answer to the question that you have. So in this case, I asked this neural network, and it doesn't matter, right? That's why it's very general, a neural network. You can ask almost any question to it. Doesn't mean that it will do it well. Depending on the question, it might not do it. But you can ask in principle any question. So if you ask, for example, will it rain tomorrow? And that was a 1 for this output. And will it be, for example, will the wind be very strong, for example, above X tomorrow? That could be a 1 or a 0 as well, right? So this would be also two questions. It could be 1, 0, here 1, 0, or here 1, 0. For example, I said that the question here would be for the output 1, will it be sunny? Will it rain tomorrow? A 1 is yes, a 0 is no. Will it be windy tomorrow? Windy, I don't know how much. A 1 here would be yes, a 0 would be no, okay? So that's what the neural network should do in this case, is this question, it's this question that you're asking. You might wonder now, how come I can ask any question to a neural network? So actually, that's the good thing about the neural network. You can ask almost any question because it consists of stuff. These circles that you see here are stuff. And this stuff, the job of this stuff, of all these things, I'll do it here, the job of all these guys, these circles that you see here, is to make it, or make an algorithm, make something to be, so work out how to make this 1 when it has to be 1, and how to make this 0 when it has to be 0, and how to make this 1 when it has to be 1, and how to make it 0. So that's the job of these guys, okay? All these guys in the middle, these circles that you see here, their job is to make the output be correct, whatever the question is, right? So now you might wonder also, okay, so I have two outputs. Can I have only one output? Definitely. You can make a neural network with one output only. For example, neural network with one output that says, where the question is, will it rain tomorrow? 1 is yes, 0 is no, for example, okay? You can have many. For example, if you want to drive an automatic car, you can ask, should I go straight, left, right, or should I stop? So you would have 4 outputs. For this would be, should I go left, should I go, number 2 would be, should I go right, number 3, should I go straight, and number 4, should I stop? Okay, so you would have as many outputs as questions that you want the network to answer, right? Which are compatible. But well, in any case, neural networks are so flexible that you can even ask 2 questions that are relevant at the same time, which probably you wouldn't get anything very good, but you could ask, will it rain tomorrow? Will people tomorrow wear blue, for example, for output number 2? You could do that as well. Anyway, so I've explained the outputs, which is the interesting thing, I think. And then the technical stuff is here, okay? Is in the middle. And I'll explain that by explaining now the input. So let's do it now, very simple. So for example, imagine that the question in the output layer is, this is a friend of mine. Vila, un momento. So yeah, a friend of mine was calling me. Anyway, the output 1 or output 2, output 1, by the way, doesn't mean it's 1. It means this is the question number 1. Output n means that you can ask n questions. 1, 2, 3, 4, 5. I said here before that there were 2. It's not correct because they wrote n here, because they mean you can ask n questions. 1, 2, 3, 4, 5, up to n. N might be 5, I don't know, whatever it is. So then you have something else here. You have, as I said, the input, okay? So what is the input? So if you want to know, for example, let's do it very simple. Let's get only one output, and let's ask this neural network if it will rain tomorrow. 1 is yes, 0 is no. It will not rain tomorrow here, right? I don't know. I don't know where here is. Could be Manchester, London, or Madrid, right? It doesn't matter. So now the issue with the neural network is which thing you input, and this is where the input by the lawyer, for example, would come in handy for a question about law, and for a question about weather, you should ask a weatherman. So because we're asking now if it will rain tomorrow, the weatherman probably has input 1. I don't know how many inputs the weatherman would like to put, but maybe input 1 would be relative humidity, right? So you want to know if the humidity tomorrow. So you say humidity 70%. That's relative humidity, yeah. Maybe today the humidity is 70%, so you put here 60. Sorry, 70 or 60. It doesn't matter. The relative humidity that you have, you input here. Input means you enter in the machine. Input 2, for example, the temperature today, for example, is in Celsius is 20 degrees Celsius, okay? So you input here. And how many inputs do you put? This is down to the expertise of the guy. So if you're a lawyer, you might tell me, for example, if the question is about law, how many times has this guy committed a crime? How many, I don't know what? You are an expert, so you need to tell me what is important to input, right? So this is why the input is about expertise. The output is how well the guy does. The guy, I mean the neural network, right? So now you have the thing in between. So this is the technical thing, and this is the beauty of the neural network, and I'll tell you what happens. So let's keep going with the thing about temperature here, about the weather for the temperature, right? So the output 1, let's put it this way. So if output is 1, and it means will it rain tomorrow, for example, you're asking a question about weather, and you input relative humidity 60 and temperature 20, and you don't use any more inputs. Maybe it's enough. With this you will get the right answer. If tomorrow it rains, it's 1, and if it doesn't, it's 0. And if it's correct, and the neural network says tomorrow it will rain 1 because of the temperature today and the relative humidity today, then the neural network did a good job. And if it says 1 and it doesn't rain, then it did a bad job, right? So you need to know how many times it did a good job and how many times it did a bad job, and then you know the accuracy and resolution of the neural network. So anyway, let's see what happens with hidden layers, right? That's why they call it deep, and you will understand very easily this. That's what I say, it's very easy. It's much easier than people think. And I'm sure you understand that because there's nothing too complex about this. Even if you're not a scientist, you don't need to be a scientist. You only need a bit of common sense. Anyway, so let's keep going. You have this, okay? You have that the output can be 1 or 0, and the question is, will it rain tomorrow? If it will rain, it will give me a 1. If it doesn't rain, it will give me a 0. And the input, we said we have to only, we put in input here the relative humidity today and the temperature today, okay? You put it into the machine, and you need to do that. You need to enter the temperature. It could be a sensor, right? A sensor can say, okay, I input it automatically. So today I put the temperature today and the relative humidity today, and then it will be the work. It will do the work on its own. So what's the automation? Okay, now what's the intelligent part of this? So the intelligent, which I don't think is intelligent anyway, I think it's mathematics and it's very simple. It's complex because the mathematics, there's a lot of mathematics, but at the end of the day, it's a very simple thing. So that's all in the hidden layers, okay? So what happens here is the following. The input, as you can see, the relative humidity, we have, let's see how many layers we have. In here we have 1, 2, and 3. So the depth of this neural network is 3. Okay, if this was a 3, it could be n also. Huh? And how many rows does it have? It has 1, 2, 3, 4. Let's imagine that it doesn't have anything here. And this is actually, you can put as many as you like. Huh? You put as many as you like, and you'll ask me, then why do you put 4? I don't know. You try with 4, and if it does well, it's good. You try with 5, if it does well, it is good. Sometimes a neural network with very few of these guys does well. Sometimes it does worse with more, okay? So it doesn't mean that the deeper the better. That's not true. And that I tell many people all the time this thing. Anyway, let's imagine that it has 3 layers, right? So the depth is 1, 2, and 3. So if the relative humidity, let's start with relative humidity. You input the relative humidity here, which is 60 relative humidity, and as you can see, this number goes into this neuron. That's why they call them neurons. It's not a neuron, it's just a box, okay? So then it goes also into this neuron, and this arrow means it also goes into this neuron, right? And this arrow, it also goes into this neuron. So now, we will do some calculations here. Which ones? It's a bit complex, but not too much, okay? But it does some calculations, and then the output it sends here, okay? It also sends here, and you see now the complexity, right? Because this neuron will send it to all other neurons, and also this guy, which is the temperature we set, for example, 20 degrees, it also sends the 20 degrees to every other neuron like this, okay? And every other neuron here, which is the first layer, also sends it to all the other ones. Now you start seeing the complexity, right? And from here to here, and from here to here, so all the neurons send the signal to every other neuron. And then this final layer, which is the depth, which here is 3, it will send, each one of them will send the signal here. I'll do it in red so you see it. And I'll put it a bit thicker, okay? This one will send it here, this one will send it here, this one will send it here, this one will send it here. So now, if these guys did a good job, okay, this neural network, this neuron will compute with these guys, with these inputs, a number, and it should be 1, or close to 1 at least, so if it will rain tomorrow. So if the result is 1, and it rains, it did well, and if the result is 1 and it doesn't rain, it did bad, okay? The same for the other, well, that was it, because we said there's only one question here, so that's the end. So this neural network has got 2 inputs, and I remind you, if you are a lawyer, for example, and the question is in the output, will this guy commit a crime? Yes, 1, no, 0, okay? And the input, as a lawyer, you might say, I don't know because I don't know law, but you might say, how many times has this guy been in prison? How many times has this guy not paid the fines? Whatever, that's the input, right? So then you choose the neural networks here, the number of layers, and the neurons, and actually there's some machines that do it automatically, they optimize this, and then if it's 1 and it was true, then you're good. Now you will understand why you need a lot of data for this. You need a lot of data because the more data you can put here, for example, if you have data about 20 guys, for example, how many times 20 people committed a crime, how many times, and 20 people, for example, didn't pay the fines how many times. So with these 20 people, you can train this thing, because you know if eventually these guys committed a crime again or not. So with this data, you will train your neural network. And that's it. I just tell you this. If you have any other questions, let me know. There's more details, but conceptually, that's all. You don't need to know anything else. It's that simple. Then there are mathematics in between, but in reality, it's not that important to know, okay? So that's it for now, and I hope you learned something with this.